Hello, platformers. Welcome to another live stream. And today we have Ahmed Bebars. Do you want to quickly introduce yourself to people who, for some reason, don't know you yet?
Yeah, there's a lot of people don't know me, so like it's good with intro. So hey everyone, my name is Ahmed Bebars. I'm a principal engineer at the New York Times, but I'm also a CNCF ambassador, organized KCD, and like I try to be involved with a lot of things Kubernetes. So if you ever have questions about Kubernetes, let's talk. Interested in hear more about what you are doing in that space.
Awesome. Just a reminder for everyone, if you have questions during the stream, just drop them in the comments below and we'll answer them as we'll go along. The topic of today is scaling smarter, not harder, with KEDA and Karpenter. We'll also touch a bit on cluster autoscaler and perhaps other CNCF tools, but we will start with that. So Ahmed, what is your experience? If you can go over a bit um, your experience using autoscalers in Kubernetes.
Yeah, so let's start. When I started a few years ago and doing Kubernetes work, it's probably like Carpenter wasn't there yet, and then like cluster scale was the only things that you can do. Basically, as far as I have seen, or the common patterns in the industry. But like it worked for a while, but like it doesn't work into like very granular spaces because that's where like it's just like it's very reactive, and the sequence out of how it scales the nodes in the cluster takes time because it really dependent on like other ABIs that it doesn't control. For example, I just like from a cluster scale perspective, as far as I understood, you just like say, hey, I need these buds, and then like scheduler does the work, and then like cluster scale, oh yeah, let me see if we have enough. We don't have enough. Let's tell someone that we don't have enough and wait on them to bring the nodes back so I can start like do the thing. And it always like do this in a less granular way. When I have seen Carpenter, it was more exciting because also like it tried to abstract a few of the pieces. I'm sure you used Carpenter, and a lot of people used Kubernetes in many shapes, but like try to like decouple the node group style. Try to like make it more like optimized for a way that you not necessarily have to have a node group to start your stuff. Sure, implementations in different cloud providers might vary in a different way. How to get Carpenter running in the first place with a node group, and then like you get to start. But the granularity out of it gives you like a lot more flexibility in how you start using scaling your nodes. That's a very good things that I have seen. The other thing is like the speed out of it because it relies on a different mechanisms. It still uses a scheduler behind the scene from Kubernetes. And I learned that recently from a meetup in New York that like when they started, they was like doing the scheduling themselves, but then they pivoted and get back to the Kubernetes schedule. So they don't try to interfere with it. And this is actually a good way of like not trying to interfere with the Kubernetes API in general and like built on top of it. So that's a helpful thing. I think you touched on that, like scaling in general. KEDA is always like, if you use Kubernetes, you're familiar with HPA, horizontal button scaler. It's been there for years. It's working, but like it's time for like more metrics to look into, and we'll dive more into like we've been like always scaling on like memory and CPU, but is that enough? I don't think it's enough, and you can see that in the new auto scaling HPA v2 where like they started to introduce more external metrics and like how you can scale beyond the CPU and memory.
So let's talk a bit about the motivation for autoscaler. So not everyone is using Carpenter, right? And what's the main driver for deciding to use them or invest in autoscalers?
So basically, like, let's be honest, like every Kubernetes cluster setup is completely different. Some clusters are really like, hey, I know my nodes, like we have like a specific like cron job, or it's a pipeline, or it's a CI/CD tool, or something specific that I don't really need to scale that much, and like autoscaler would fit the use case. Because when you want to like talk about Carpenter provides a lot of speed, and also provides a lot of granularity. But like you may not need that in some cases. The one thing that I always mention to anyone is just like every component you add in your platform, it's a component that you have to operate. It means like you have to upgrade, you have to maintain, you have to understand when it goes wrong. So if you don't need it, just don't use it. So try to find the problems that you are trying to solve for first. Karpenter brings you granularity, brings you speed of scaling, brings you different things that like it's upcoming, it's different from like the cluster auto scale. Giving you an example. With Karpenter, there's like this feature about TTL, or like how long the nodes can be alive. So you can set this to like, for example, 14 days. You don't have to worry about batching anymore. Then like it just like goes up and down, like your old nodes get rotated even if there's no scaling capability. So there are more to the operational piece of things. You can start like have multiple for example, like multiple like workload types. You can start to diverse, have like a smaller node pool for like some of the tenants. If you run multi-tenant, for example, that's another thing to go for. Also, like you have like all of this drift and capabilities about disruption and like how like you scale all of that. So it provides a lot of capabilities, but you might not need it. So it's just like not because Karpenter is great, you just like should go implement it. You just like have to figure out, do I have scaling problem? Is that even a problem for my platform? And then go there. So always my motto here is just like find a problem, then find a solution. Don't just like do the opposite and just like, hey, Carpenter's great, let's get it. It's more of like what problem it's solving.
Let's talk about cost for a bit. We talked about the performance, the speed, the granularity, and how much is cost motivation for using autoscalers like Karpenter?
That's a really great segue into it. So like here's the thing. When we have been doing like auto scaling groups in different cloud providers, usually you have to set which node types you want. And this is like you define the size, and basically like the auto scaling mechanism works on like specific types. So you either like have a launch template or configuration, say these are the types that I know specifically, these are the sizes. And the point with it, it's like the one thing that I'm seeing is like it's incremental. What I mean by that, let's assume we pick AWS for the sake of the example and say like I have T3 large node pool, and then like my next one is always going to be like T3 large node pool. I can add one more, like add more or less, but it's incremental from node size. What Karpenter is great at is that in the same node pool, you don't necessarily have to stick to a specific type or a specific size. You could stick to a family, but you can also go granular and say like I always want this specific machine. So what this helps is like behind the scene in Karpenter, and one time I had to read through the understanding is like it does look at many areas. It does look at what's the best price. Does this node pool support spot versus on demand? Can I go like big this? So there's a lot of decision making happening on that stack that can allow you in some way to get better cost effective. Like, and also like Karpenter does like all of that bin backing mechanism. So from a consolidation perspective, let's assume that like, hey, I'm running like these 10,000 buds or 500, wherever. And then they are running in a different shapes and machines, and I scaled and already everything looks good. But let's assume there's a better availability for like different node types. So what Karpenter does behind the scene is does consolidation. So it like removes all of these nodes that like might be like less cost effective and bring like better nodes that are more cost effective. So from that perspective, it just like, you know, when you have like an auto mode, I don't want to say auto mode because AKS supports auto mode now, but like you have auto way of like making it better if you have less requirements. Some use cases you just like want to compute, but like I have seen other use cases where like, oh, I need that specific node type, specific node class, specific node size. These are different stories, but we're talking about like I just need like a CPU that works, or I need a GPU that works. And if my application is, one of the good things that I have seen is like my application is tolerant enough to understand spot termination, because spot comes with like termination, like your application need to understand like how to handle that gracefully. That Karpenter can do this like on the fly. Like, okay, that looks like we can bake between spot and on demand. Let me try spot first. Spot's not available. Let me go for on demand. So it just gives you more flexibility on like how you scale and optimize for that element of cost as well.
And let me ask you, have you ever had to troubleshoot a workload and you spent a lot of hours on it, and then you found out, oh, it's Karpenter killed this node, and that's why I'm having this issue right now?
Not personally, I heard stories, but like personally, I didn't see like a story where Carpenter killed this, because like the logs for Carpenter, just like you have to understand them, but like they are clear. When there is an action has been taken in the logs, you can see like what really happened, and if you have this set up correctly, you can see like, hey, we are shut down this node because like it's a spot termination handler is in place or whatever, and then we need to require another thing. Usually, if your application is less fault tolerant, and like I'm gonna be honest about this, Kubernetes in general, it's ephemeral by nature, so to speak, that like you run a container. It's not a machine. So like your application need to be tolerant to like all of these situations. Some cases you might need a volume or things attached to the node. I understand that from one perspective, but like if you depend on like, hey, I need to have this container running all the time on the same machine and everything, like if you backing it, might not be the right place from that process, because this whole platform is like container orchestrator. So it does what it's best to get you the CBU to execute whatever you have in your container. But I heard stories. That like, hey, I was doing this, and then all of a sudden my application is not working. Or stories that I heard too, if you don't configure things correctly, you might have like a very edge cases issues. For example, like one of the things that I know for Karpenter specifically, Karpenter would be able to, you can lock your AMI for AMI for like AWS and say like, I always need that AMI. But like also one of the good approaches is like, let Karpenter big the latest one and then like go for it. What could happen in a situation like this, you use, for example, let's assume your application is dependent on a specific feature in the kernel that does like different things, and you get a new node and your application start misbehaving. That's because there's an upgrade. These are tricky ones to find. I heard stories. So, and some of them are okay stories and some of them are horror stories. But if you have like your metrics right in place, if you have like your logs right in place, if you know where to look, the hardest piece is like where to look at things. One thing that I have seen is if you go too granular on the Karpenter specs for how you want to scale, you may get hit with like things that you don't expect. So for example, like this might not be a Karpenter problem, but it might be like just a cloud provider problem. You're trying to get a specific type of a node, or you're trying to get a specific pool of nodes in a specific AZ, and it's not available. And you didn't give Karpenter too much a leeway of choosing other options for you. You might just like find yourself in a spot where like, I can't scale anymore. It's not Karpenter issue. It's more like of the backing, but like Karpenter logs show you like, hey, we can do that because it's this, or like spot is not available, or like AC tunes that AZ is not there. If you let it just like go with like less granularity, that might be helpful. But if you have if you are too specific, that means you know exactly where you want to scale or how you want to scale.
All right. So you mentioned the decision matrix. So what are key metrics and thresholds that should be included in a decision matrix for scaling? And
yes.
And how do you know which scaling, how to trigger which scaling events with KEDA or Karpenter?
Yeah, that's a very good question. And like, to be honest, it varies based on the use cases. So like let's start with a couple of use cases. There are use cases where like I'm a CBU heavy application. So that's all I need to do is CBU focused and memory. I know my application consumes that. So the more in CBU and memory, the more it's useful. But like this is also like in some cases might be old. Like give you another example. Let's say I'm running a CI/CD pipeline, and it's not about CPU, it's about like jobs, like, or a queue. So how I scale that just to fulfill the queue faster. So for example, like I can have KEDA listen to a trigger or a matrix that like scale on the number of queue. What's KEDA good at? It first couple things. KEDA is built on top of HPA. So I love when things are not trying to reinvent the wheel and they are built on like, hey, I'm abstracting this more and adding more functionality to it. So what's happening is I can set like a bunch of different metrics. I could set my external metrics as well to do that stuff and then like work. This way it helps me scale on different things. So let's assume I have a job processor that like listen to a queue. SQS, for example, or something from Azure or something. I know that KEDA supports AWS and Azure. I don't know if it supports GCP yet, but like I'm listening to a queue, get more messages, and then I want to process them quickly. I'm just like fire up 10 containers, just process them, get back. That's easier. That's KEDA. KEDA and Karpenter work like a side to side from my perspective, because that's where like KEDAs really care about the containers themselves. So like how I want to scale my deployment, jobs, containers, all of that kind of stuff. Karpenter works like how I scale the nodes. So if you combine both together, you get the best scaling opportunities that you can get for like scaling fast and also like scaling on different metrics. Some use cases that you may have seen is like with a lot of these scalers that are community based, what SCADA is good at also like you can build your external scaler. What does that mean is if you have something custom, a specific metric, specific combination you can do, that's great. The other things that I have seen with SCADA, I tried it, but I didn't use it. I have like my approaches and my reasons on it. The HTTP scaler for KEDA, which is interesting because now you can scale your services to 0, which is something that we have seen with Knative in the past, where like you scale your service to 0, and then when that traffic comes in, my only design philosophy on this part is that like you have to funnel all of your traffic into like a listener for KEDA to understand, which is sounds right technically speaking. I'm not disagreeing on it, but in a high demand traffic environment, that might be a bottleneck where like how this happen. So I have seen use cases where people start to scale on Istio metric, for example, or like an envoy metric. So they would scale like their gateways and things like that based on how many traffics can come in, and this can come handy in many situations.
You just as you said that there was a big thunder and lightning behind me. So maybe that's a cue for us to do a little recap. You said a lot of things. Let's break it down into actionable tips. All right. So let's do like what's the number one thing people should keep in mind, like if they're writing down notes. And
sure, if they are writing down notes, so use the right metric for your application. So try to understand like what is you want from the scaling mechanism. So you have to identify, is it CPU, is it memory, is it something else? Each application is different. So you have to figure out what metrics first. And if this metrics is uncommon, also write them down, because you might be able to write something to make your application scale for. That's one. KEDA and Karpenter are two different pieces. They work together in parallel. That like KEDA is more for like your containers and your buds, your deployments, versus Karpenter is more focused on your nodes, the compute infrastructure power that you have in your cluster. These are like the top things, unless and you also have to understand that Kubernetes is not serverless. That's another problem that we talk about later. But
yeah, we'll get to that. And you also mentioned redundancy, I think, no, in terms of like how to prevent Karpenter from killing nodes and like leaving your workloads evicted.
Yeah, so metrics in Karpenter. So like the one thing that like we can't disagree on, and I believe like if you disagree with me, let me know. But we might not be friends anymore.
No, I don't want to risk that.
Okay. So metrics are important. Like if you have any tool, you need to have the metrics behind it. And Karpenter provides you with all of the metrics necessary to like understand like how Karpenter scales, how Karpenter consolidate, does all of the work from that. So you have every component that you install anywhere, just see the metric, see what does that mean, how does it impact your application, how to impact your infrastructure. That's very important to look at from a perspective of observability in general.
Perfect. And I have another philosophical question for you. So we talked about the difficulty of identifying issues that are perhaps stemming from autoscalers. If I'm a developer, maybe I don't even know what autoscalers are. I know that there's a thing called pod, that's an abstraction of my application, and something goes on. Like how do you educate developers? How do you create processes where they're like they can communicate well and you can close the loop on those types of issues rather than letting them, just wander around and then at the end it comes back to you.
Yeah, that's a very good thing. Like, let's always my best advice when it comes to this. Like, let's start from the smallest piece and goes a way up. So works away. So like, I'm deploying an application. I probably know that application is consists of a deployment and buds, and this is all I know. So I start from events to see like what's happening to my deployment. Is it like there is always something helpful, but like you have to look, you have to know where you're looking for. So like the status of a bud, good reflective of like, can I get the runtimes that I need or not? So if it's pending in a while, there's no space for you to set. So that means like there's a bigger problem, there's a node problem. And that might not give you the clearest indication, but like if you look at a bud as bending and then you go look at your deployment, you would see like, okay, it's trying to scale something, but there's no nodes enough for that. So that gives you indication where to go next. Why I don't have nodes. And then you can start looking to like the nodes themselves. You may be like, it's a steps, like it's just going from the smallest piece to the bigger piece to get like why my nodes are not coming. Maybe some cases I have seen or like nodes are coming, but like your bud doesn't have the right toleration for a taint on the node.
Right.
So that like all the nodes are being provisioned as expected, but then your bud can't be there. That could be like a misconfiguration, or like that could be like a change in something. Usually if things are working fine and then they are not working fine, that there's a change in the middle that you have to figure like what really happened. And this is the hardest piece. It's just like to figure out like what is the change causing the problem. But I always try to start from the smallest piece, go up to the stack, understanding like it's a stack trace for me, how to get to the bottom of the issue.
And then a developer can always go like, okay, this is above my pay grade. This is related to infra mode, and I should ask my DevOps or platform engineer or whoever owns the cluster or the autoscalers of the cluster.
That's a good way. Like usually it's always like also like the industry right now, there's a lot of things like I have a pattern myself. If there's something that like can't search for 15 minutes and I couldn't find anything, I should go ask someone just to figure out like where is it. And like in any organizations, there's always like a different processes and tools that help you like debug these things on your own. And like there are different ways of like looking at it. You just have to set in the environment, figure your right tools that help you figure out of it. And like you don't know what you don't know. So like a good question, hey, I'm trying to do this, it always worked, but today's not working. Maybe something changed or a different thing happened you're just not aware of. So that's also a good way of figuring it out.
All right, and we have some shout outs from the audience. Mariano is saying thank you for giving the best explanation on how to use KEDA and Karpenter in conjunction. So thank you for that, Mariano. And you mentioned something about serverless, right? So let's talk about how does auto scaling in Kubernetes differ from serverless solution like Lambdas, and what does that imply for the workload design and its cost?
Yeah. So let's just like be sure and like I always love this question because it has a lot into it. And like it's not a fight between between Kubernetes and serverless. They are different from like characteristics and how they serve traffic in a different way. Like when I look at Carpenter, keep Carpenter in the way. But when I look at
Mm,
Kubernetes in general, you have a container. It's most of the time, it's necessarily to be up all the time because it's serving requests. Scales ups and down in a way that like not significant, but like there are use cases where like, hey, sure, I want to scale from like 10 to 20, 20 to 100. But like if you are in that really like very fluctuating up and down, we have to understand like the semantics behind it because that might not be the right solution because also like if it's very unknown behavior, serverless might fit a better use case because the ways that like there's a lot of things happen when you just try to scale an application. You have to scale an application, keep schedule work on it, nodes, all of the kind of stuff. There's nodes, there's provisionings, there's daemon sets, there's a bunch of things happening in that space to get you to like a place where you want to be. Then you go to serverless. It's that simple invocation. It's container running in whatever. Like, is it Google
mm,
Cloud Function? It's if it's fast, like some people like run their own. There's like the new thing right now about WASM and like how you run your lambdas and or your functions in a way. There's AWS lambdas. There's many things, and they are orchestrated in a different way. So like they are more in the nature of like event driven scaling, where like I can do a lot of things API gateway, and I'm not saying like you can't have Lambda held with an API gateway, but like it's always an architecture decisions that you have to look at it. Like what I'm really trying to solve. Like some problems that I have seen is like I'm taking like a very big monolithic application, I'm trying to put it in Lambdas, and then like the question is that the right way of doing it? Maybe it's not. It's really depends on the use case. If your application is getting invoked all the time, how you gonna do all of that abstraction and pieces between a smaller lambda functions? Where I see lambda shines a lot of the time, and like the ability to scaling super fast, and you have seen like for example like AWS and how they can scale tremendously fast because
yeah.
they use different hypervisor, Firecracker, and different things. But they're also like the use cases here like varies between that. I don't think I have seen Kubernetes scale faster like this. And if we are trying to make Kubernetes scale like Lambda, I think like you just like, why not use Lambda? So maybe like you
Mm,
use the traffic stability, the things for like your Kubernetes because it serves like a better scope. Also, like there's a lot of things that you get with Kubernetes that you may get or you may not get from your cloud function. You got like internal routing between multiple services. For example, like people using service mesh for reason, for authentication, for all of that kind of stuff. I don't think you can get this with Lambda out of the box. Sure, there are tools and things. I'm not saying like it's not ever available, but it's a like it's a two different ecosystems. I can't compare EC2 for example to containers and Kubernetes because it's just like a different semantics, different way of doing.
all
So
right.
I can't really compare Kubernetes to Lambda specifically. I feel like they two serve two different purposes, and you can have applications use the two of them in conjunction. If you have something that like fluctuates so fast, maybe Lambda would serve that better. But then you have like your steady traffic APIs that scales up and down. Maybe that sets in your Kubernetes cluster. So back again, what is the problem? What are we trying to solve? Let's go for that and then figure out a way of going this way or that way.
And from your experience, your current company or past places where you worked, and what you've seen and going on in the world, so how do you decide how do you decide when you need lambdas and when you need Kubernetes? How do you decide when to use KEDA or HPA, Karpenter? cluster autoscaler. There's so much choice, and like we haven't even touched on like other tools that are less popular. But how do you make that choice?
Yeah. So it's always there's a time where like you're not aware of like what's there, and then like you have to start like experience a problem. So in all of my roles, my current company or previous companies, I have seen like I go for about like what I'm solving for is like, okay, let's talk about. Usually there are not too many tools in the market that you can rely on, because also one thing that I have to consider really well is like, what is the ecosystem? When we talk about open source, it's very important to pick a project that like have contributions, that like there's adoption for it, because you don't want to pick something that it doesn't really like. You always can be an early adapter, but then like puts more burden on you to like contribute to it and all of the kind of stuff. So you wanna also like be cautious about like which project to pick. But it's always like an iterative approach. You never go like from zero to hero. Doesn't work this way. So you always start like, okay, I'll start with like, I need a Kubernetes cluster autoscaler. What I have seen in my entire career, it's always like cluster autoscaler comes first. Maybe like this is like was like until up to 3-4 years ago. Or yeah, a couple years ago. Then Karpenter started to become the default of like, hey, this is the way that like you get Karpenter store. But like there are a lot of people still not using Karpenter, and that's completely fine because it fits the narrative, it fits the use case. And then you go like, we start scaling memory and CPU. It's just like it's always a default, and it's gonna become the default because applications are built that way. Like CPU and memory are the two things that like your application consume most of the time that you need to scale on. So I need to scale on these, and then you go from there. You ask a good question about like when I should decide. That's usually an architectural decision that you decide like depends on like how you build your application. So let's assume I'm coming today, I'm building a new complete system. I have a clear requirement or clear set of requirement. So I can start to say like, this need to be steady. This is fluctuating. How I would do that. That's probably where you start like, which tool serves that purpose first. That's one way of doing it. Other ways of doing it is like starting one way and then scaling from there. So ways that I have seen that happen in either refactor or a replatform, someone started in Kubernetes because that's where like it's easier. In organizations, usually the hardest part is like, it's not like how to start. It's more like the adoption, the majority, like the experience, all of that kind of stuff. You ask me a question, say like, I'm a developer trying to trying to debug something. Let's assume I'm the only one in my company using Kubernetes. What's going to be for me to do that? I have to maintain the cluster. I have to maintain the stuff. I have to know everything just to run it. But like that situation changed completely if my entire company is using Kubernetes. So it's always like, that's also like a good decision factor. Like, are you the only one in the organizations that you're running through that use case or not? That might be like a one, because if you're an early adopter for something, you have to understand that like you're taking the burden of like understanding where to go. It's not the wrong thing. Don't get me wrong on this. Like we're like, hey, I shouldn't do that. In some cases, that might be a beneficial for your architecture, but that's where I think like you should look at. So like I would say like personally, from my personal experience, even for like my stuff, if you're asking me like, hey, I have a service, should I start Kubernetes? And so you're like, if you have a service when you start in Kubernetes, that might be like a hard thing, maybe with the EKS order mode and the things, but I still see this hard because like you're losing a lot of the things that it comes with Kubernetes. It comes for an architecture of a microservice and all of that kind of stuff. Most of these cases, your work could start from a Lambda. If I'm transforming something simple, like I have a very clear thing, like giving you an example, have a website that like I wanted to go from one domain to do a redirect to a different domain. I could build this whole thing in Kubernetes, but it's going to be overly complex in doing it just to change that. So the whole thing that I do, just like put it behind the CDN and then like have a Lambda to do the redirect for me. That's simple enough to do. Or like I'm processing an event. That's simple enough for me to do in an ecosystem of Lambda, for example. But if I have like multi-service applications, and I have an order service and then a checkout service and then multiple pieces, usually your first instinct would be like, that seems to be the right way in Kubernetes. And that's usually most of the cases, right? But you might start from there, like, but our checkout service, it's heavy, for example, or like have some requirements that need to scale fast because we sell, like we do a drop, like that might, Kubernetes might not be the right choice. So it's always an architecture decisions that happen, and always have to, the one thing that I love to say about this, it's always iterative, and you have to find escape hatches in your uh designs where like I can go from here to there. Like it's just like, it's always have to be a way of like, if I deployed something to my Kubernetes and it didn't work, can I have the same interface or the same load balance or the same wherever, but then traffic my work to Lambda? That could be a good way of doing it. I don't know if that's too much, but that's my experience.
No, that was a good lesson for people. I hope they were writing it down at home. And I would also add to that, like you said, if you're the only person who works with Kubernetes and you have to do everything yourself, that makes sense. I would add to that it's just not sustainable, or it's not scalable, right? You can't be like in an organization like where you work, you can't be just one person owning all of Kubernetes. Like you would usually need a bigger team. And what do you think about also, even when Kubernetes is adopted across the organization, you still have varying degrees of expertise, right? So if you're the platform engineer, you probably know a lot about infrastructure and about Kubernetes, but then you have the developers who know significantly less. And maybe you have like data science teams that know nothing about the underlying infrastructure in Kubernetes, and you would have to adapt to each team or use case, right?
Yeah, that's absolutely right. It doesn't mean if the organization, any organization is using Kubernetes, that everyone is like familiar with Kubernetes. They might know like, hey, it exists. I might know just like, hey, there's a deployment, there's a pod. I have seen an organization where like they even abstract that layer completely, and they have like a manifest, for example, that say, we create our own CRD to do this, and all you need to do is just to fill something and you get it out. I've seen organization do it in Helm. There's like this new open source project called Crew, which is Kubernetes Resource Orchestrator, which is something interesting as well. It's like a new thing that like allow you to define like a resource definition, or Kubernetes resource definition, and then like it consists of like, Kubernetes is not easy by default. It's just like, to get an application deployed, you need a deployment, at least a deployment and a service. Like when you start like with Kubernetes, like the first intro usually like how to create a bud, but like that works when you do a playground. Then like you go to production, it's like consists of like different things. How like my deployment work, like can I get my HPA to scale? Can I get my service? And if you are using Istio and other things or any other service mesh, just a bunch of things. So abstracting these pieces sometimes are helpful to organize and standardize this in a scope, and then always have a specialized teams in like a specific areas that could be helpful. Yeah, and keep in mind, Kubernetes is always ephemeral, so like let's not make it non-ephemeral orchestration.
Yeah, and you mentioned Crew, so mark the date next week, same time. Our Carlos Santana and Shani will be covering Crew as well. So just a week from now, if it piques your interest, then
it piqued my interest for sure, and like I'll come to the stream. I always love to hear Carlos' thoughts about it.
Yeah, me too. I'll be there. All right, so we covered a lot of ground here. Let's see, how about we talk about how to customize autoscalers, or how can we leverage KEDA's hyper customizable triggers to build an event-driven strategy?
Yeah, so that's a really good use case that I heard, and like one of the good things about KEDA, it's like it's trying to create like a different mechanism of scaling. So if you go to keda.sh, if I believe this is the correct website, you're gonna find like all of the available scalars, and this rapidly grow from like, can I scale on Dynamo? Can I scale on like an SQS? Can I scale on Radis? Can I scale on different things? And this is where like the benefit of like understanding the architecture for it. So you could find yourself scaling in many things. And like, here's the thing, like usually applications like have a multiple dependencies across different things. So CPU and memory, not because you're using KEDA, you shouldn't scale on them. Like, why not? They are still the same metrics that the application still used to scale and do things and process things. So that's one thing. But like, I could want to scale on a cron job, for example. Like, let's assume I'm doing like my like I'm doing batch processing only on the day. At the night, I don't do anything. So I scale on CPU, I scale on memory, and I scale on cron job. In the morning, I get like my scaling up. Like I say, like, hey, scale to like 100 deployment, 100 buds in the morning, and then scale it down. Use case. Can I scale on SQS if I get more messages? Have seen like use cases where like I'm processing orders. I want to process them fast. I only have capacity for 5 buds. So, but like, what if I get 1,000 message because I did a flash sale? Can I scale on that? Sure. Let's scale on that. So it's not like one or nothing. It's probably most of the use cases, it's more than one thing that you should scale on. But each application is going to be different. Some applications might be writing or reading from DynamoDB. So that's where you should scale on, besides CPU and memory and other things. So the ways that like you can scale on multiple metrics, it's super helpful because like you are not blindsided in only like, is it CPU and memory? There are also good use cases where like, if we go out of the box, let's say I want to rescale like you know the pre-warming for load balancers, for example. So that's a way of like, hey, we anticipate traffic on that day, so like can we do that? You can set up a customer scaler that like just a trigger, like maybe a UI or a feature flag or something that say like, I need more. So it's outside it, listen to a metric and just like trigger more or pre-worm bots for you so they are ready to accept traffic. So that's where like I actually find that customizable triggers super help you with like, if you combine KEDA and Karpenter in the same point, that were like, oh, that's like a great duo of like how I scale my Kubernetes cluster all. And yeah, there are more use cases. There are more complex use cases that I have seen, but like the more complex we go, the more like it's just you have to start like putting pieces together. But the good thing, it's always extendable. So the good thing about KEDA is that you can create your external scalars and just like create an external scalar that will listen to, and then like you scale based on that. That could be a button, could be something, could be just your voice. If you love automation, you can say, hey, Alexa, scale this. That would work. You know.
Yeah, it's going to be an interesting collaboration within Amazon, doing Alexa and AWS Q and Carpenter. I have a quick question here from Mariano again, asking about where to find good information, saying that the documentation is oftentimes incomplete, vague, or superficial. Just my input, and feel free to disagree. I think Carpenter actually has a very good documentation, and so does KEDA, being a CNCF project. I think is pretty well maintained. But what do you think?
Yeah, both of them are an open source project under the CNCF umbrella. So like definitely go to carpenter.sh, keda.sh. I believe these are the right sites. And like I agree with you, documentation sometimes don't serve all of the purposes because people like a maintainer or someone always writing it from their perspective to the best of use case. That's where a community can help. If you find something that it's not useful enough, maybe like raise a pull request, maybe just ask about it, and maybe like try to push for a better documentation. Like we just like it's something that we have to cooperate all on. And also like the Slack for CNCF is a helpful place where you can ask questions if you don't know some things. There's always I recall there's a channel for Karpenter. I remember that, and I believe there's a channel for KEDA. I'm not sure. I can check, but like there's always going to be a channel somewhere for like things that you can do. And if you don't find these channels, maybe the Karpenter, that Kubernetes Slack also like would have more of these projects available. But like reach out on the website, open a pull request, open an issue, and then if no one responds to you, just let's work it from there, and let's start that point first and then see where else. And Mariano, feel free to reach out to me if you have a specific question. Can help direct you to the right people as well. So if I don't know the info, I will help you to get it. So
For sure, and I hope you're part of the Platformers Slack, where we also have a lot of helpful people who want to learn together and grow. And we're closing in on our time. So before we wrap up, and by the way, we have some announcements we are saving for the ending. So stay tuned. We are almost done. And stay with us to find out what we have to share. But before we do, and before we recap all of the awesome knowledge that Ahmed dropped on us here, I want to ask you about some horror stories or some things to look out for. Let's not say horror stories, but things that could go wrong, could go horribly wrong, and things to keep in mind when going on this auto-scaling journey.
yeah, that's a very good one. Okay, so I'll tell you a story from like work that I was doing with different organization, and then someone was asking me, and we were discussing it. What things could go wrong is what you don't expect. So imagine that you're running in a car, and then the car should speed, and then the engine you keep pressing the pedal to get more gas, but then the engine is not responding to you. What I have seen in some cases is like you may not see this, but Carpenter or any other tool, just like using CPU and memory and operation to just like scale and do the things. Uh, Controllers in general are like, I don't want to say tough pieces, but like they are delicate to work with when you work in Kubernetes controllers. So one use case that I have seen, and it was like a very nightmare for the person who told me about it. They were like everything was like on a very scaling fast, and things were going great, and like everything was working, and all of a sudden nothing is scaling, and just like we're like, and this was like one of the stories where like we keep scaling, things are rapidly increasing, and it was like a moment where like it was like a very I believe that was either Black Friday or Cyber Monday. Someone was like telling me a story about this, and then he was like, nothing's scaling anymore, and like we just don't know what's happening wrong, and like all of a sudden Carpenter got in a crash loop because it's just like running out of memory, trying to like get from one. If you're having like a high availability in controllers, usually you have multiple buds running the same thing, but like at certain levels you can like scale the controller beyond its own ability that it runs out of CPU or memory fast. And these are the situations where like your engine doing your entire scaling, it doesn't work, so you are left on with like a lot of requests that you cannot fulfill. And these moments are like really depends on like how good is your matrix. If you are able to detect these earlier, that would be great. But in that specific use case, it took a while to get to like why we are not getting these, because Carpenter was working, but it's kind of in a situation where it's crashing. It's just like it starts, get all of the data, trying to process too many, gets like really in an kill situation, and then like that's where it goes. So observability is a key in all of your stack. If you don't have it, you're probably like just driving blindly. You don't know where you're going.
Yeah, and that is quite dangerous. And we talked about KEDA and Karpenter going hand in hand, and KEDA and HPA also closely coupled. Have you ever seen a case of someone using Karpenter and cluster autoscaler in conjunction?
No, and that's dangerous to do. Like, they can be against each other because Carpenter does something, Oscaler does something else. Oscaler based on node groups. They can, like, technically everything can if you just like set it the right way. I don't know what would be the use case out of it. The one use case that I could have in mind, which is like usually because Carpenter needs nodes to run on. So basically, you need to get like at least a node or two first. Usually, people get a node group or something first, put Carpenter on, and then like let Carpenter dictate what other nodes gonna come be. So you might want to book cluster or scale for that, but like I would say, why? Because like it's just like you need one or two things to run there, and then the rest of your fleet, Carpenter can manage it. The one thing that I have seen running together is Carpenter and proportional cluster autoscaler, because proportional cluster autoscaler is different. It's not based on how I scale the deployment or I get nodes. It's more of like how I understand the size of the cluster with the amount of things. The one thing that really resonated with me is core DNS, for example. If you use Kubernetes, use core DNS. If you have like 3 nodes cluster, you probably need like a couple pods of core DNS, and that would do the job. But if you have like 10,000 nodes, you just like need more. So proportional cluster autoscaler helps in that capacity where it can like understand the node size and like basically say, okay, now we need like more core node DNS, but it doesn't play with the nodes specifically. It's just like more of like scaling a deployment or scaling it that way. So these are, I could see work together. I have heard use cases on them working together, but I didn't basically, and I don't recommend using the same tool to do two things at the same time, because there's always a conflict somewhere. Even if you don't see it immediately, there's always an edge case where you might run into someone is trying to scale. It might be cost ineffective. So yeah, that's my take on it.
No, it's a good point, and I'm glad we talked about it right after the car analogy, because this is like doing it without observability. You said it's like driving blindly, then using cluster autoscaler and Karpenter is like what, trying to drive with 2 wheels or something, or 2 cars, or I don't know. But yeah, so we talked about some pitfalls. Before we wrap this up and share our exciting announcements, you want to give a quick recap of like the top things to keep in mind for those who want a summary or missed the entire stream?
Sure. Fix a problem, then figure out what is the right tool for it. Carpenter is good for scaling Kubernetes with a lot of granularity that you can have around like how to maintain your entire fleet. KEDA is another amazing addition to the HPA that you can use for like different metrics, different scaling mechanisms. Both of them can work together in conjunction and actually provide a better way of like how I scale my deployments, how I can scale my nodes, how I can scale the cluster. Kubernetes and Lambdas, or Kubernetes and serverless, are 2 different ecosystems. You can combine them if it's needed architecturally speaking, but like, let's not compare like what's best, because each has like its moment of doing like, I'm doing the right thing in that space, I'm doing the right thing in that space. Then we talked about like hyperscalers, like there's always a way to do like custom metrics and all of the things in KEDA that can support. So check out all of that metrics that KEDA support out of the box. If there's a metric that you couldn't find, it's time you to open source and write your own metric, or you write your internal metric for your organization. That might something that just like apply to your use case. So also try to do that. But that's all.
All right, awesome. Thank you so much for coming on the show and sharing your knowledge with everyone. I hope everyone's been taking notes. And before we go, do you want to share a bit some of the things you have coming up in
Yes.
your Kubernetes life?
Yeah, so in my Kubernetes lives, the first things that you always, if you are around New York, you can come to the meetup, we can chat. But the next thing coming is like I'm going to be in a KubeCon London. So if you are going, let's talk. I'm gonna be there. Feel free to reach out. And if you are around New York, and if you heard about Kubernetes Community Days, which is basically uh like a less crowded way of like KubeCon. KubeCon is too big and sometimes might be
Mhm.
overwhelming for people who are starting. Like if you are in New York and like you want to start talk with people, we do Kubernetes Community Day in New York. That's gonna happen in June 4th. This year, it's a good way of like chatting with people in the community, spending a day. It's also like a single day, so it should like grab different things. We will have great speakers, great keynotes, good activities. It's in the middle of Manhattan, so like it's very commutable. And if you have any questions, reach out as a one who want to attend. If you're also interested in sponsoring the event, let us know. It's a very community driven. Myself and the rest of the organizer team, we are like putting all of that effort to bring a good event to the community and share more about the knowledge. So yeah, just reach out and we'll figure a way to cooperate together.
Yeah, I highly recommend. I will also be at KubeCon, so feel free to hit me up and meet me there. What Ahmed was too modest to mention is that he's also speaking there, so you can catch him also on stage sharing more of his knowledge. And finally, we have something exciting we want to share. So, as you know, we are starting a new year with a new live stream agenda and a lot of other cool activities. And we have awesome people joining us along the way, like Carlos Santana and May and Shani, who you know from other streams. And now we have another awesome member joining our team, and his name is Ahmed Bebars.
I'm super
So
excited about this,
mm,
Odi, and thank you for the invite. Hopefully, it will be great. I see the amount of effort that you put with the team into like sharing more, and like I'm super passionate to like be part of that community and try, all learn something new together. I'm always striving to learn, so I really appreciate the opportunity, and I appreciate you inviting me uh, to be part of the team.
awesome, yeah, and I feel the same way. Myself and Guy, when we started this community, we never imagined that we could have people like you and Carlos join us, and this is super awesome and exciting. And I feel like this is just the beginning. So now we're gonna continue this journey together. Next time, maybe you will be on the other side of this stream and hosting some cool person. And we have congrats from the audience from Matthew. Thank you for that. And thank you, everyone else, for listening in. And thank you, Ahmed, and have a great day. And see you next time.
See you next time.